Hey everyone.
Hey, hello and welcome everyone. We will just wait for a couple of more minutes for people to join, so hang out with us.
Yeah, you can say hi in the chat. You can type where are you listening and watching from. We'll be happy to know our geography. Just say hi and where I'm from.
We'll check if the comments work.
Yes, it's also an important part. We want to be able. If you will have any questions during the stream, you can ask them right there. We'll see. We'll either answer them during the stream or after it.
Yeah, we'll do our best to answer as much
Yes.
as possible.
Oh, Costa Rica. Hello, Alberto. Yeah, and demonstration works also.
Oh yeah, we can highlight the comments and.
Can you do it?
No, I can't.
No, it's only me.
Yeah.
Sorry, I'm the host today. But I like this feeling of power in my hands.
Yes, definitely.
Oh, hello from Balkans, from Masha. Hi, Masha. Portugal, I like it. Hi, Caro. Geography is nice. It's at the same. Is Costa Rica in the south hemisphere or north hemisphere?
I think it's Central America, and I'm not sure where it
That's
is.
why I'm asking. Yeah.
Yeah, regarding to the Ecuador. Yeah.
Hi, Emilio from Spain. Thank you for joining. We are popular in Portugal. Nice.
Yes,
Hi,
here we are.
Rumi. I guess not Rumi. How do you read this name, by the way? I don't know. Sorry, I didn't mean to butcher it. It's 3 minutes after the hour.
Yeah, no, Alberto, we know that it's Central America. We just wonder if it's a Southern Hemisphere or Northern Hemisphere.
Yes. Oh, so it's between Panama and Nicaragua. I believe it should be Southern Hemisphere already. But, okay. I shouldn't be lazy. I will just open my Google Maps.
Oh, or we can wait for Alberto to tell us. Yes, but it's a beautiful place. There is the nature is just amazing.
No, it's southern. I was wrong. Even the topmost part of Brazil is still northern. Even the topmost part of Brazil is northern hemisphere, and the whole Costa Rica and whole Venezuela and Suriname are in the northern hemisphere too.
Here you go. And we have Rob from the UK and Mamoudou from France. This is excellent.
Hi, Rob. And hi, Mamoudou from France.
And Marco from Italy. That's that's a very, very nice geography here. Definitely. All right. Okay. So I think we can start, and people will join as we progress. So we're going to talk today about not only surviving but actually thriving on older Java versions. Hi, Stefan from Germany.
Yeah, it's totally not about surviving. We'll expand a little bit on it a bit later.
Yeah. So I don't know if you realized, but most of the Java JVM runtimes in the world are still Java 8 or Java 11. It came as a surprise for me, for example, because I knew that it was so a couple of years ago, but I was surprised that it's still the case.
Well, we'll see what changes with Java 25. Some people just do not have enough push. Maybe it will shift, but to be honest with you, I do not think that Java 8 is going anywhere in any foreseeable future.
Oh yeah. No, Java 8 is not going anywhere for a very obvious very obvious reason. Java 9 was so disruptive that it really broke a lot of mission critical applications in the Java world, including infrastructure stuff that people are still dependent on. So for example, if you use application servers like WebSphere or maybe WebLogic, you will probably have to run on Java 8 because a lot of the magic that those application servers do just don't work in Java 9.
Yeah, and you're talking about JPMS, Java Module System, right? Because as far as I remember, it was the only disruptive thing. But we can argue
it was disruptive enough that we are now more than 10 years after, and still we see a huge chunk of the industry on Java 8 because of that.
It is slowly declining, and there are many companies who tries to help people to migrate, because sometimes it's painful. For example, Moderna with its Open Rewrite tries to help you to migrate between Java versions, but we know that it's not always possible. It's not always feasible, and actually, it usually doesn't make any sense to do it, right?
Yeah. So we're going to talk about it in a second. First, couple of words about us. This is Pasha, your host for Today, developer advocate with Bellsoft.
And this is Baruch Sadagursky, head of DevRel at TaxCare. Thank you for joining me.
Pasha, thank you very much for having me. And the reason why we're both here is that because we both know a lot about how to thrive on older Java versions, coming from our personal experience with, I think, combined probably over 40 years of Java development.
Also, we started with Java's much long before Java 8. You started at 1.3. 1.3. I started at 1.5, and they're completely different languages. And in a way, we can say that Java 25 is another completely different language from Java 8. I had a video about it on YouTube, desugaring Java from Java 23 to Java 1.1, and it was quite a challenge. It's actually 2 videos in a row. But I'm not sure if you want to migrate and if you need to migrate, because...
Exactly, right. So not everybody can migrate, and not everybody want to migrate or should migrate. There are many reasons not to do it. For example, it might be a system that the migration doesn't make any economic sense, right? Because the source code is large enough and complicated enough that it's just not, and it works, and everything good with it, and everything is good with what already works within existing constraints. So if you have this,
we have this label, like if it's an old version of Java, then something is wrong with it. But it's actually not the case. And the best proof for it, the fact that this very code still exists, because, well, someone pays for it, and it means you have active clients, your company has active clients, the product is feasible, probably popular, probably it's an internal product, and it doesn't need to be popular, but it works well enough for you and for your company. So do you actually need to look for any economical reasons to rewrite it? Because if it ain't broken, don't fix it.
Yeah, and so if you find yourself one of those or more than one of those statements kind of refer to you, you're in the right place, right? If you're maintaining mature Java systems and you are in teams that are responsible for applications built on Java 8 or maybe Java 11, and you are not going to migrate because of business priorities, because it just works, because it doesn't make sense, but you still want to kind of improve your system, writing cleaner code, using modern maybe concepts of software development, and you want to make sure that security and safety are not slipping away while you are on the older version. And you actually are pragmatic about what you are doing. You are not throwing like a tantrum about, hey, I need the latest Java, but you approach your code base pragmatically and look for pragmatic improvements that you can do now, even if you are not rewriting anything from scratch. Then this webinar is definitely for you.
I would even say there is one more prerequisite. You probably need to be willing to become happy or to be happy developing this. Because I mean, being pragmatic is very nice, but you should care about your, I don't know, well-being, including psychological well-being. You should care. You should try to be happy within this code base, even if you are not the biggest fan of Java 8 or whatever legacy code you have, right?
And it's not even about like trying of being happy. It's actually being happy. There is nothing wrong with
thriving. Like you,
and it can be even better, right?
But
so we'll get to it.
To
We'll get
be
to it.
happy. Sorry.
Yeah,
be
we'll get
happy.
to it in a second. Let's first talk about why the upgrade stall, right? So there are reasons that we already mentioned, like systems just work and the risk is greater than the reward. And we spoke about the vendor lock-in challenges, stuff like if you are on WebSphere or WebLogic, you probably cannot just upgrade. Business priorities that actually make sense. But it's more important to deliver features than to rewrite everything. And one that we actually didn't manage is the fear of breaking things, because rewriting a complex system might be a very disappointing and failed project. And you sometimes just don't want to do it because of the risk of this failure.
And this risk, it's not something like hard to imagine. I know a lot of systems which are even tested in production, and they have significant number of tests, but can you ever be sure that you have enough tests in your test suite? Like
Exactly.
You're rewriting your code and your tests pass, and I can totally imagine myself deploying this code on production, and suddenly a client which hits weird, bizarre corner case comes to me and says, Pash, it doesn't work anymore. And I'm like, what should I do? I know what I should do. I should roll back my system. I should write new tests. I should rewrite my logics again, and so on. This fear, what I mean to say, this fear is very, very reasonable, and you shouldn't pretend that this possibility doesn't exist. It totally exists.
Yep. All right, let's move forward, and just before we getting into like the real meat of this presentation, we just want to assure you that we are there with you, right? There is nothing dirty in legacy. There is nothing inherently wrong in running older versions.
I spent literal years working with legacy code, and in a way it was the most rewarding experience I've had, because you can learn a lot from complex systems, you can improve a lot usually, and today we will spend some time talking about improvement at least potential space for improvement. But learning is essential. It's impossible to learn new things with shiny new things that just work. Like these real experts, they're born in a battle, right? And sometimes legacy code is this battle, but you can approach it in a smart way.
Exactly. So let's talk about that. Let's talk about what you can do. So we will talk about how even running on Java 8 and Java 11, you can still utilize some of the modern feeling code and some of the modern concepts that came to Java later, and you might not use them is exactly the same way, but you will get very close feel to writing much more modern Java that your platform allows you.
Of course, we will speak about runtime performance, because usually the language is not about the syntax of the language, it's about how your actual software works and how it's felt by your customers, your users, and so on. They are the people who usually care about performance, and sometimes there are ways to improve performance, not breaking anything, and sometimes not even updating Java.
Yep. We're going to talk about running something that, again, in terms of architecture, considered more modern stuff, like maybe microservices or general like architectural improvements that you can definitely do even on more legacy code bases. And we're going to talk about that. And we're going to talk about security that how can you catch up with all the latest security patches and the protections, even while being on the older versions.
It's actually funny that we told so many good things about legacy, but we didn't mention that there is a fear regarding, and it's a very reasonable fear regarding legacy. We can't guarantee its security, right?
Yes, we're going to talk about that, and we'll touch about that, and then we'll see that we actually can alleviate this fear and make sure that our code is as secure as the latest versions without almost any effort. So let's start with code. Yeah.
Do you want to do it? Or do you think-
Yeah. So let's start with code. So basically, the idea is that sometimes when you write for an older JVM, you cannot really use the latest version, the latest features, right? So there is a lot of new features in Java that came out in latest versions, and you might feel missing out on those features, stuff like var, stuff like records, other stuff.
Now, but fear is actually very real. Again, it's very real. It's FOMO, right?
Yeah, absolutely. No, it's 100%. Today, writing Java today is much nicer experience than writing Java 10 years ago. There is no doubt about it, and we cannot pretend otherwise. But in the end of the day, clean and clear code is even more important than using latest idioms, right?
Absolutely.
Yeah.
And latest idioms just help you sometimes to avoid writing dirty code, unclean code, imperfect code, but it doesn't mean that it's impossible. It is totally possible to write clear, concise code in Java 8 with all its features. Java 8 was already very much powerful language. It's very far away from Go, for example, which is very, let's call it, simplistic compared to Java. Java has everything.
Absolutely. Yeah,
and we can save some lines of code with Java 25 for sure, but there are other ways to save these lines of code too. The thing we should care about is architecture and understandability, maintainability of our code base, right?
Yes, and the biggest leap was actually Java 8, right? So the difference between Java 5 and Java 8 is much more important than difference between Java 8 and Java 25. So if you are on Java 8, you're already past this chasm in which like Java became the how should I say, the more powerful, idiomatic, cleaner, and generally more modern language. You are already in the right half of it. And so everything past it is still very nice additions, but the critical chasm was Java 8. So you are already in a language with streams, with optional, with generics. Should I mention?
I had a small story here. When we'd been using Java 6 at one of my first employers, we were dreaming on Java 7 because there should be generics in Java 7. And
no, Java 5. Generics were in Java 5.
No, not generics. Sorry, it's lambdas in Java 7 and so on. And then it was released, and Java 7 almost didn't contain any features.
Yeah.
And then we were like, come on, and a huge gap between Java 8. And I remember this feeling when the Java 8 was finally released by Oracle. It was like everyone at my company started migrating products to Java 8 the same day. Not to streams, not necessarily to streams. Streams were considered complicated and so on, but in general to Java 8 because they had so many nice features. Especially lambdas, you don't need to define, I don't know, iterator anymore, like in a complex way. You can define it right in a lambda and so on. It was so nice.
Yeah. So Java 8 you already have. Good. What else can you have? So, for example, you can use tools like Project Lombok, which adds a lot of modern feature-like additions to Java 8 and Java 11. For example, we're going to see this example in a second, stuff like record, which is, I think, Java, 21?
21, I think, yes.
Yeah, 21
yes,
is completely doable on Java 8 and Java 11 using Lombok.
May I interject just for a little bit? There is a controversy around Lombok. Not everyone likes Lombok, and there are reasons. Lombok kind of works in a bizarre way. It hijacks your compilation process, and it changes it. It is formally an annotation processor which should generate a code, but it actually doesn't generate any code. It changes bytecode which Java generates, and some people are afraid of it. So you should be cautious about Lombok. Probably, it's not the best possible solution for you. If sometimes it makes projects fragile, but on the other hand, look at this slide. On the left, we see usual POJO, plain old Java object, with 3 fields and at least 7 lines, additional lines, getters, setters, and constructor, right?
Now, they're not 7 lines. We don't write inline getters.
They're 21 lines.
Exactly.
Because and constructor is probably 3 additional lines. So it is like 25 lines we do not care about. And if we use this product inside HashMap, or if you want to have any level of debuggability at all, we should also define toString hashcode and equals, and we should care about hashcode equals contract, right? When objects are equal, their hashcode should be identical. Vice versa is not necessary, but this way, this side is necessary. That's a lot of code. That's a lot of code, and Java 21 solves it in a nice way. They have these records. You just put everything in the parentheses and your curly braces after parentheses, and that's done. Like you have your equals hashcode, toString getters. You don't have setters, to be honest. Records are immutable.
Yeah, but you can do the same immutability with Lombok. So Lombok actually gives you more flexibility. You can generate records which are immutable, or data classes which are mutable, and just save you on the getter and setters and stuff. Now, yeah. Pasha, getting back to your point about how Lombok, the fear of Lombok magic, I would call it, right? So yes, there is this point that there is a lot of magic happening in compilation process, but I don't buy this argument. Java does a lot of magic in compilation process.
Okay.
The source code that you have and the bytecode that you get in the end are not exactly the same. But even for people who claim that you lose traceability and what you get in the end is not exactly what you can trace to the source code and what's not, I have 2 solutions. The first is modern IDEs, IntelliJ in particular, do a great job of bringing this traceability back. So in debugging, you will land at the right places, even though your bytecode is not now matching any source code because Lombok...
not completely correct, to be honest.
So IntelliJ fixes that. And if it's still not enough, you actually have a way to generate classic Java source from Lombok source in a process that it's called delomboking, which is funny. And you can actually have an intermediate source generated by your build, so you can always go and look and see what Lombok did exactly. So your main source code is very readable, it's very clear, it feels very Java 21. And if you ever run into the problem that, hey, my bytecode doesn't know where the source code is for debugging traceability and what's not, you can always defer to this source code which is delomboked, and it will look like your Java 8, Java 11, and then will match the bytecode precisely.
I actually had a conversation about it with Sergey Gorev, our good friend, some time ago in Twitter. So it was very public. Anyone can find it on Twitter. And he kind of agreed with me that data is sometimes dangerous because imagine you're using Hibernate, which is totally a possibility in the bigger companies, right? Hibernate has very specific requirements for equals hash code and so on, which are not fulfilled by the data annotation. So you should be cautious. You can't.
Oh no, but this is just a matter of overriding what you need. If you override in your data class hash code and equals, this is what will work. It doesn't really. It's not really different from having overriding hash code and equals in any traditional Java pod job.
Absolutely.
If you don't override it, you have one behavior. If you override it, you have another behavior, and it's not different with Lombok.
Just be mindful of your tools. You should know your tool. This is probably the most important part here. Like you should know how it works and what it will change.
Yeah. So some of the stuff that Lombok does for you, we saw the data, the boilerplate eliminator that generates a lot of code for us. We talked about value, which creates actually what is now in Java called record, and it's a mutable data class that is generally a good practice to use. There is an amazing builder annotation that generates builder pattern out of the box. I'm sure you know about the builder pattern, and you know how powerful it is. It also comes with a lot of boilerplate to create add builder annotation in Lombok, makes it a breeze, and again, highly recommended.
Yeah, and also builders just became better in Lombok. I learned it only like a week ago. You can now create deep builders because like if your entity includes another entity, you will have extends another entity. Your builder will support all the fields from upper level entities too, which is amazing. Another project which achieves the same goal by slightly different means is called Jilt, but it is not being close to by popularity to Lombok, and it only essentially does builders. Also, another annotation in Lombok we don't have on this slide is sneaky throws.
Oh yeah.
Because a lot of people.
Let's get to sneaky throws in a second. Let's talk about the logger annotation. So the most common boilerplate line in any Java code, any Java class is the private static final logger. Logger equals logger factory get logger. Right? It's there. There is no escape from it. You will have it in any class until you plug Lombok in. Once you did it, you just create a logger field. You annotate it with SLF4J or other logger annotations, depending on the logger that you works, and it's just there. It's a tiny thing, but it transforms how your code is written, how your code is read, and it's generally a small thing that goes a very long way. And another annotation that Pasha just mentioned is sneaky throw. Sneaky throw, there is another very annoying Java boilerplate, and this is checked exception that is thrown inside runtime code that doesn't declare this exception.
Many people are saying that probably checked exceptions are the biggest error in Java design. I'm not in the position to argue about this. It's very questionable. But
I'm not sold on that. There is a valid debate whether checked exceptions are a good idea or not. Regardless, there are use cases in which check exception is just pain in the ass. And this is where you overriding a method which doesn't declare any checked exception, and then you use something that throws these checked exceptions in it. You have no way to work around it except of wrapping the check exception in runtime exception and then rethrowing this runtime exception. This is stupid. This is annoying. Everybody do it. Everybody hate it until you put a small annotation sneaky throws on your method and it will be done for you. There is no magic. It does exactly that. It wraps the exception in runtime exception and rethrow it. The only difference is you don't need to write it, and that it's a big difference.
Yes, and another reason to not use checked exceptions is Spring framework. It is built on top of idea that there are no checked exceptions anywhere. Like transactions are being rolled back only if the exception is runtime. Interesting. Okay. Only if the exception is a runtime exception. And you can't work it around. Again, you should wrap your exception in the runtime exception and throw it, or I don't know, write a crazy amount of boilerplate. And sometimes there are cases when the checked exception is declared, but it actually can't be thrown. For example, you create byte array output stream, and you write something into this byte array output stream. Write method in output stream declares IO exception, but it's obviously impossible for IO exception to be created when you write to just essentially a byte array, right? It shouldn't be there, but this is how Java works. Sneaky throws kind of solve this issue.
Yeah. So a lot of goodness in Lombok. Use it, enjoy it. It's great. Another project that does that aims to do the same is called Jabal.
It is developed by our friend Sergey.
Speaking about Sergey Egorov, right?
I mean, he's everywhere. Test containers, Jabal, JRebel, probably a lot of other projects.
Yeah.
So yeah, like he's a very well-known person. So his idea was, why should I struggle? Why can't I use newer Java features in older Java? Technically, they're not supported, right? But we can desugar them. For example, var, which is a variable in Java, we can totally deduce the type during the compilation time and replace the var annotation with actual type, and we will have perfectly valid bytecode. This is how it looks.
If you are on Java 8, you don't have the type inference.
Yes.
And then obviously you mentioned the class all over again, on the left side declaring the variable, on the right side creating objects out of it, etc., etc. Java 10 introduced the var variable, but you can still use var in Java 8 or 9 if you use Jabal. So here is an example. It's much clearer.
You can see that almost nothing changed.
Yeah.
We didn't put an example of how to attach Jabal to a project, but it's very, very simple. It's just a small legend. All the types are omitted here and replaced with var. And this is all. Like, you don't need to do any changes in your code. And it's much, much less magical than Lombok. If you're still afraid of Lombok, you can look at Jabal. It is a highly experimental.
It also does much less. I would say combination of both brings you closer to a modern Java syntax.
You're right, but it's also about risk management, right? And here we should say that Jabal is very experimental. Sergey doesn't have a lot of time to maintain it. So if you are interested, you can contact us or just find Sergey, and we will help you. We hopefully will be able to guide you in usage and so on.
Right. All right. So this is how you modernize your code. Let's now talk about architecture.
Yes, your code is not only your syntax, and I would even argue, your code is mostly not syntax. Your code is mostly the architecture of your code, because when it's a big legacy system, obviously it knows how to do a lot of things, and you need to control your architecture. And there is an amazing tool which works for Java 8, and it's called ArchUnit, which, like JUnit, just tests your Java. ArchUnit tests your architecture. You can define the rules, like this package can call this package, but not vice versa, which usually happens in big code bases. You have controllers and services for obvious reasons shouldn't call controllers, because single responsibility principle, right? and it can detect violation, report them during the build time, which is very important. And it's also crazy fast. It's not like you need to run a huge test suite to understand if you broke something or not. It's as fast as your usual unit tests. And it integrates with Surefire in case of Maven, or just test in case of Gradle. It's perfectly aligned with the whole Java ecosystem. Let's show a small example of the code. Here is how it looks like. I omitted one line. So Arch rule definition obviously stands for, we are trying to define a rule here, and we say that classes that reside in a package controller should only depend on classes that reside in any of packages, Java, JavaX, controller, and service. Usually it will be slightly different because, for example, you use Spring, so you will have to declare that you also want to depend on classes, org, Spring Framework, and so on. But this is the whole idea. And then it calls check classes. Classes should be defined like somewhere on the top level. It's just a classes residing somewhere. It's just one line of code, and this definition is very concise, and in my opinion, it's very, very readable. Even if it's your like, I don't know, third day of Java, it's already a readable test. If you know what package is, hopefully you do, because packages are everywhere in Java. And this is simple. And as soon as you run this code, you will, on the whole project, just imagine the situation. Today, you join this legacy project. You add one dependency to your project. You add this one test. And you immediately know if there are any breaks of this rule. And if there are, then first, you're on a good track to fix something, and I don't know, achievement unlocked and so on, probably raise whatever. Second, you know at least some issues with your software. You can declare that there should not be cyclic dependencies between your Spring beans, and Arch Unit can validate it, and sometimes it's important. You probably know that Spring supports cyclic dependencies between beans, but the fact that it supports cyclic dependencies doesn't automatically mean
that you should do it.
Yes, that you should do it. Let's move forward.
All right. So so how do you integrate Arch Unit?
Essentially, you just add your dependency to Maven or Gradle, whatever it is. You define, I suggest to define one rule and slowly add them. Probably as soon as you will define one rule, you will see some contract breaks, and you will have to fix them or decide that you don't want to fix them for whatever reasons. Probably you want to delete this rule. But then slowly, this amount of rules grows up. And in the end, ultimately, you have perfectly structured project with very well-known definitions and readable definitions. Anyone who joins the project can read all your Arch Unit tests. You saw them, they're relatively simple, and understand how the project's structured, and they won't be able accidentally to break your architecture. And then you just execute them, and you put these tests into your CI, whatever it is, Jenkins, with, I don't know, GitHub Actions, whatever, and it just works.
Beautiful.
It is.
Okay, next topic is, okay, now, you mentioned it already in the beginning, and I think you had a very, very important point. The only quality that matters, which includes performance as well, is what the customers experience. The customers really couldn't care less if your code is written on Java 25, Java 8, or Java 5. All they want to have is highly performant application that does exactly what they want. So regardless of how dirty, old, unmaintainable your source code is, what important even more is how fast it works.
Yeah, how responsible it is usually. Like, yes. Fast is a very broad.
How
responsible is very, very understandable. Yeah. Your client who opens the page should open the result of execution, I don't know, in 200 milliseconds or something like that.
And one of the biggest differences between modern Java versions, the Java 25, Java 21, you name it, and older versions, Java 8, Java 11, is performance. Yes. So I don't know if you have numbers by how much the performance of Java virtual machine increased over those years.
Oh, I have a lot of numbers actually, but it depends on what you are measuring. For example, and which garbage collector we are talking about, because Java is very, very tunable, and even in Java 8, garbage collectors are amazing. But for example, G1 garbage collector in Java 8, if you will switch to the next slide, we will probably see something there. Can you please switch the slide? Yeah, it's here. So in some tests, we have 99.99% of latency decrease of new G1 in Liberica Performance Edition compared to G1
original
in the Java 8. And this is the first time I mentioned in Liberica Performance Edition, even though you saw it in the previous slide.
Yeah. What is it? Yes.
It's an absolutely beautiful idea implemented by Bellsoft. Imagine you have all your source code written in Java 8, and currently it's running on Java 8, but you can swap virtual machine, do not change a single line of code, and suddenly run on Java 21. So underneath it's Java 21, but somehow it's made fully compatible with your old source code, which means it doesn't care about JPMS, it doesn't break anything in your code. And if it breaks anything in your code, then you have our support, you come to us, you say that I have this issue, and we fix it because we are responsible, it's our product, and so on. And it's not just like a weird deviation. We have just released the new version several days ago. What was it? I believe it was, give me a second, 2 days ago, we released the new version of Java Liberica Performance Edition. Just to remind you, Liberica is OpenJDK, so you can download it free. It's not that simple with Liberica Performance Edition, but you will see the QR code in the end where you can request a trial of Liberica Performance Edition. We'll come back to this later. And numbers in benchmarks are just amazing. But when we go to the real world application, it becomes slightly more difficult and slightly more diverse. But I still have these beautiful numbers, like 20% improvement in latency and 15% improvement in throughput on real world applications, on the bigger ones. And I have this demo, but it's a topic for a whole separate talk. Let's go further.
Yeah. So so that's kind of that's a very big deal because in the end of the day, regardless of the code you write, the perceived performance is in the eye of the end user. And one of the main reasons for wanting to update to modern JVM is performance. And this closes this gap very, very elegantly.
What we should say is happy customer is a happy developer, means happy developer.
Absolutely.
When your product manager sees that customers are happy, you get all the possible benefits from the development.
Yes.
And all the necessary experience.
Yeah. So what else can we say about, I think this slide is kind of out of sequence. It should follow the arc unit, but yeah, sorry about that.
But observability is a very important point, right? Observability is not connected in any way to Arch unit. It's about tools you use, and many tools work nicely with Java 8. Like you can use APMs, modern APMs with all the code bases, and you probably want to do it. I'm not sure if you can use Signos, which is open source, but you for sure can use Datadog, for example, which is compatible with Java 8, and you can closely follow all your metrics, performance metrics, and otherwise, and see if everything goes well.
Absolutely. Now let's talk about risks and about particularly security risks. Now, one of the biggest pains of running on all Java versions is that you become a very easy target for hackers and cyber criminals. They actively seek legacy systems because they know that there are a lot of libraries and frameworks in those systems that are almost guaranteed not to be patched against modern security vulnerabilities, just because a lot of those libraries and frameworks are not maintained anymore for those major versions. And that means that the security patches are not applied to them and that the system is vulnerable. Not only this, you have a huge target on your back, you're also almost automatically out of compliance, because if those frameworks and libraries are not patched, that means that your compliance targets cannot be achieved. And again, even the compliance auditors are more suspicious of the older versions and will probably be more particular in their audits, knowing that there is a lot to be found if you use older versions. And obviously that brings for security breaches with data breaches, which are very, very expensive for companies, both because of the government punishment and the cost of the data breach itself, and obviously reputational damages that come with it. So
actually, I was shocked to know that, for example, United States Air Force doesn't use any Java below Java 22.
Yes.
Not even Java 21, Java 22.
Yes.
This is because this is the only simple way for them to mitigate risks. But there is another solution, right?
The thing is, if you don't have budget of US Department of Defense, and you don't, you probably cannot allow those massive rewrites of everything to the latest version of Java just to mitigate security risks. There are much cheaper ways to achieve the following. There are companies, and TaxCare, the company that I work for, is one of them, that actually provide extended support after the official end of life. So, for example, if you are still on Java 8 because maybe you use an application server, that means that you will use necessarily older version of Spring Framework or Spring Boot, because Spring Framework and Spring Boot both dropped support for Java 8 a couple of versions ago. And we are now at end of life of those older versions. No more patches for them, and that means that you are fully exposed. Using extended support from TaxCare, for example, you can get the security patches from the latest versions of Spring backported into older versions of Spring, so you can still be on Java 8 and Java 11. You can still be on those older versions of your framework, Spring or whatever else, Hibernate, etc., and still get the security patches that will take you off the list of possible exposure to cyber attacks and governance audits and all this kind of stuff.
And obviously, Belsoft does the same for Java in commercial support. We just had a case when one potential customer came to us and said, our government entity forces us to move from Java 4 to Java 6 because Java 4 is way too unsecure. And if you can help us in migration, we'll be your client and so on. So we spent 2 months on it. I can't name names, but it's a big company. Many people know about it. And we helped them to migrate. And now they're happy customers, still on Java 6, but at least then, and Java 6 is long time end of life. We help them to keep their code base as secure as possible. We think that it's very close to being zero CVE, which is very nice. And probably it's the only way to do it. The only way to keep secure, to keep yourself secure, is to buy services from companies who provide this service.
Yeah, no, I mean, theoretically, you can backport the fixes yourself.
Yeah, but
it's probably not your core business. That's probably not what you want to do. But what you cannot afford is just ignore it and say, well, we will stay on the latest version of this major version and we will ignore everything that happens after.
But you know that it's impossible for Java, right? It's impossible for Java because vulnerabilities for Java are not ever fully announced publicly. So you don't even know in which part of the Java this vulnerability was found. You don't know which particular patch addresses it. And also backporting C++ patches to, I don't know, Java 6 or to Java 4 is almost impossible. I mean, if you are not a professional like our guys who do it for a living.
Yeah. Not fun. It's not fun even for open source projects, even for Spring, when you actually know exactly where and what was vulnerable. Still backporting it. It's not your job. It's not something that you actually.
Oh, we have a beautiful question here.
Yeah.
If they wanted to update anyway, why not to the newer Java then? Because they realize that even 4.6 is expensive, and the further you go, the more expensive time-wise. I'm not even speaking about money. Time-wise, it becomes.
Migration from Java 4 to Java 25 is impossible. It's a full rewrite of the entire code. There will be nothing left, and obviously, it doesn't make any sense.
Migrating economically, it doesn't make any sense. Time-wise, it doesn't make any sense.
Yeah, and from 6 to 8, and then from 8 to 11, and then from 11 to 15, and this is how you get into modern ones. But it's definitely not happening in day one. We're talking about multi-year projects, and during this time, you want the features, you want the performance, and you want the security. So how does it work? As simple as it gets, right? You once we give you access to the repository that contains our patched versions of these older libraries, you just update your build config, your POM.xml, your build Gradle. You basically start referring to our bill of materials that will list all the patched versions instead of original versions. You run your build. You don't change anything in your code. You don't change anything in your build except of referring to the new bill of materials, and you are completely protected. We will let you know when new versions of bill of materials are ready, so you can test them before you put them in production. And obviously, you get support for any frameworks and libraries that you need. And it's a sliding window. There are some libraries that you manage to upgrade, and then you don't need end-of-life endless support for it. There are new libraries that you are using, they fall out of end of life, and then you need support for them. So this is a sliding window when the companies like Taxcare, and Taxcare in particular, obviously, got your back always. It's kind of an insurance policy, or that whatever you use will be covered and will be protected regardless of when you need it, for how long you need it. Is it just a temporary before you upgrade, or the upgrade is not coming and you need the support for a long time?
I have a question.
Yes.
What does the word endless mean?
So that's exactly that, right? We will provide you with lifecycle support for as long as you need it, basically.
Nice.
Right? So
even if Spring 7 is already released, you will still support Spring 1.
Exactly. It doesn't matter what is the latest version. The only thing that matters is that if there are security patches that are released in the newer versions, you are guaranteed to have them with SLA within very short time in your older version for you to be protected.
And can you support any libraries, or is it only Spring ecosystem?
No, we support any library. We have obviously a catalog of libraries that are currently in our repository, but the process of backporting vulnerabilities is almost fully automated, and it's the same for almost every library or framework. So if you don't find what you need, we will make sure that you get it within the same SLA within your subscription. You don't need to pay per library. You pay per this protection across your entire application.
This is beautiful. Thank you.
So yeah, just to sum up, we are kind of closing on an hour here. Legacy is not a bad word, and definitely working on legacy is not bad engineering. There are reasons why those systems still work, because they actually are good. They're
Yes.
durable, they are successful, and this is the reason why they are still up and not replaced by anything else.
Yeah, I would even say that it's a perk of being a good engineering. There might be flaws, because flaws, you can find flaws everywhere, but it doesn't mean that they are bad. They're amazing because they are feasible. And also, you as a developer, you're not just writing code, you are actually responsible for your whole product. In a way, it doesn't mean that you will be, I don't know, demoted if something happens, but you kind of should care about this product. And this is what craftsmanship is about. You are responsible for the performance of your product. So tomorrow, if you think that you have issues with security, you can go to your management and say, hey, I heard about this tax care, probably we want their services. Or if you know that you have issues with performance, you probably want to talk to them about performance edition, who knows?
Absolutely, absolutely. And in the end of the day, we are talking about the end goal, that systems that are secure and performant for the users. You can do a lot within those constraints, even on the older versions of Java. And I hope we teach you some new tricks in this area. So in the end of the day, modern code, architecture and testing, performance and security, those are the 4 pillars of what we call legacy Java excellence. This is where you can improve dramatically, and not only it will improve the posture of your application, it will actually improve your life, because you will have much more satisfaction and pleasure working on, even if you are not in the latest version of Java.
You forgot about clients again, but you will also improve lives of your clients,
of course,
which is the cornerstone of any successful business.
Of course, of course. So with that, we have like 2 minutes for Q&A. I think way in the beginning, we had a question that I would like to answer.
Which one?
Yes, general solution to relaunch Java 8 projects with new version of Java from Stellar. That's unfortunately something that was never a thing. You see it, Pasha?
No. Where do you see
It's just two comments up before the question that you answered about newer Java version.
Like this
yes,
one?
There you go. Yeah.
It would be nicer that, yeah. Well,
so
I mean, isn't Liberica Performance Edition not that?
It's I think the idea is that can we write syntax of Java 25 and then compile it to Java 8? Now, originally in Java, in the older versions of Java 2, and that's everything under Java 5, that was actually possible.
Yep.
You could write code in Java 1.4 and then compile it to run on Java 1.2 JVM.
Because they could do desugaring, and it was a deliberate decision by Oracle to change this.
Exactly.
Because it actually costs too much to implement it for every possible language feature, and what is even worse, for every combination of language features. Because usually it's about combination, but Jable is very close to this. Again, it doesn't support the all variety of Java language features, but maybe if your company is interested in it, you can talk to Sergey, and probably he would be interested to support it. If you will look at the code of Jabel, it's relatively small. It is very maintainable, and I'm actually surprised by how small it is.
Yeah. So, just to answer the question, yes, it was possible, and this is why some of the flags are so deceiving. You have the source code level and the bytecode level, and it looks like you can set any combination between the two, and that's just a leftover from the days that you actually could do it. But it's not true for 20 years by now. And since Java 5, it doesn't work, and you will get an error.
I think it's Java 6, isn't it?
Maybe Java 6, that it's illegal combinations of those flags, and this is why we need stuff like everything that we mentioned today, Jabel, Lombok, Liberica Performance Edition, etc. All right. So with that, we don't have any more questions, if I see it correctly.
Yeah, and we're closed an hour, so I mean.
Yeah.
Okay, there is actually a question.
Yeah.
Is there any way to run upgrade to Java 21, a system made on Java 8? JackOrp? Sorry, I'm not familiar with it. Do you know JackOrp?
No, I have no idea what it is.
I guess it's somehow related to Corba, but sorry. But please write me an email, write me in Twitter, in Blue Sky, wherever, and I will happily research and answer you the question as soon as possible. I don't have the question.
Yeah, so right from now. Like 20 seconds Googling, it's a free Java implementation of Corba standard. Yeah.
Oh, so I guessed correctly. I mean, still don't have an answer.
No.
But
let's research. It's
Liberica Performance Edition. If Corba was still a thing in Java 8, then Liberica Performance Edition should have it.
Yeah. We'll check. So thank you all very much. We hope
we need to open the last slide. There are QR codes.
Oh yeah, for sure. Yes. So what you do? You try Liberica Performance Edition by scanning this QR code. You try ELS for Spring. This is just one example. Or you can request any other library or framework to try it. This is another QR code. For more questions, customized request, personal guidance, anything else, reach out to us, Pasha Finkelstein and Bellsoft
sw.com and jbaruch
at taxcare.com will probably be easier. jbaruch at taxcare.com. That's the work email that it's easy to remember. With that, thank you very much, Pasha. It was a pleasure. Thank you for having me.
Thank you, everyone, and thank you, Baruch, for coming. It was a pleasure talking to you as always. Let's remove this screen. They will be able to hit the pause when they need it. Pop. Folks, thank you, everyone, for coming. I was happy to see you there. It was a beautiful chat. They were a beautiful question. I hope to see you soon, but just let me know what you're interested in. And
thank you very much, and bye-bye.
Have a nice rest of your day. Bye-bye.